A very visual sense of an arithmetic progression can be seen with the Cuisiner rods that we use with children when they are younger. And as we put these, the gaps are consistent is very obvious to see. It's a gap of 1, and it's a very visual picture. So I think one of the things we ask is what is the sum of an AP? So this is not a sequence, we're talking about I meant series, which is the sum of these elements in a sequence. So once you have a pattern like this, you have 5 or you have 6. Then you can use the visual picture and say, okay, if I had exactly the same pattern, 6, 5, 4, 3, 2, 1. Yeah, even if the sum of one set of these is difficult to be able to guess, once you put these two together, two of the same, then you can see that if you were adding these 6 numbers, the height is 6 plus 1, 7. So the sum, the area of this, or the sum of all these numbers, which is the area of this, is 6 times 7 and half of that, because half of it is this and half of it is that. The same thing is repeated 2 times. So this is the sum of, this can basically get you whenever you have n into n plus 1. But easier way of doing that is once children see a pattern, then you can write down numbers and you can say, we start with the odd numbers, let's say 4 plus 5 plus 6 plus 7, right? If you were adding up to 7, for example, here you are adding up to 6. So you work with the odd numbers, then you can say, okay, this is, we know that this is 7 times 8 by 2, but it's also easier to just see this as, this n into n plus 1 by 2 is a little harder for children, but you say, okay, there's 1 7 here, there's a second 7, there's a third 7, there's a fourth 7. So it's easier to do this calculation because one number will be an odd number, the next number will be even. So you can just say this is 7 times 4. There are 4 7s which you can show them. If you take another simpler odd number, you just take 5, you say 1 plus 2 plus 3 plus 4 plus 5. Then you can say, yes, we have 5 times 6 by 2, but basically it means there's 1 5 which is here, right? Then we have a second 5 and we have a third 5. That's it. So you just have 3 5s. So the 6 by 2 is 3 5s, which is 15. So you can introduce series, which is the sum of sequences, by using what is told Gauss has done, and much earlier than that in India as well, of course. So we start with the odd numbers and say, that means there are 3 2s. Right? There are 2 3s, fine. Because one of them is this, the other one is this. So for the odd numbers, it's easy to see this number, and then there are so many of those. After you've done this and you've explained that it is n into n plus 1 by 2, you can take, if you only added up till here, right? Then you need the same pattern as you have here. The 6s are out. So now it becomes 5 here and 6 here. So the pattern is always n into n plus 1 by 2, but the calculation is much easier. But when you remember that you don't need to multiply and then divide by 2, but you just need to divide it by 2 early enough, because one of the numbers will be even. Now if the number of numbers is even, right, so then it's easier to just see this addition and then say you cancel this out, you get 2, so you have 2 5s, so that's 1 5, this is the second 5. Or if you are going up to 6, 1 plus 2 plus 3 plus 5 plus 6, There are even numbers, you have pairs for everything. So you have a pair for this. Okay, sorry, I was using the other color. You have a pair for this and you have a pair for this. They all add up to 7. So and there are 3 pairs, which is 7 times 6 by 2. 3 pairs. So these patterns children can see both with the numbers as well as with the addition, what we are doing.